Hello everyone, today we are going to start lecture 02 of class 8 mathematics chapter number 7, which is cubes and cube roots. Now in this lecture we are going to talk about column method to find the cube of a number, which is a bit faster than the conventional multiplication method. But before that, let me remind you that you should learn the cubes of at least first 20 natural numbers in order to make your calculations faster. Okay, so these are the tables and you should learn them. Now let us talk about the column method, which we are going to study in this particular lecture to determine the cube of a number. Now what is this column method? If you recall, we have studied this column method same in the square roots also. We have used this method to find the square of a 2-digit number. Similarly, in this lecture we are going to use this method to find the cube of a 2-digit number. So this method actually works on an identity, and we all know that the identity which it works on is a plus b whole cube. So a plus b whole cube is equals to a cube plus 3a square b plus 3ab square plus b cube. Similarly, in the case of squares, our method was based on a plus b whole square, which was a square plus 2ab plus b square. So we are going to use this method, that is, we have to construct four columns in a table, and we have to use that particular table, that column method, to find the cube of a 2-digit number. The two digits are a and b, where b will be the unit digit of the number and a will be the tens digit. Okay, here comma, in two-digit number ab, comma, b is the units digit and a is the tens digit, right? So suppose if you are calculating cube of 25, then 5 would be the unit digit and 2 will be the tens digit. Okay, so in two-digit number ab, b is the unit digit and a is the 10 digit. We will make how many columns? 4 columns. We will make 4 columns. Okay, since its name is column method, so there must be some columns involved, right? So we will make 4 columns. What are the 4 columns? The first column will have a cube in this order. Second column will have 3a square b. Third column will have 3ab square. And fourth and final column will have b cube. Okay, so there will be 4 columns, and then we will follow a particular procedure with particular steps to find the cube of a number. Okay, example, let us find, for the demonstration of the method, for the demonstration of the steps, let us find the cube of 25. Okay, let us calculate 25 cube using this column method. So let me recall that this method will use the identity a plus b whole cube. So you should always remember this particular identity and in this format only. Okay, so it will have 4 terms. So the number of terms in this identity will determine the number of columns here. In the case of square, the number of terms were 3 and the columns were also 3, right? So in a 2-digit number ab, we will take b as a units digit and a is the tens digit. So let us find the cube of 25, right? So the column method and the first step says, that take a is equals to 2 and b is equals to 5, right? So ab would be 25. Then write the values of a cube, 3a square b, 3ab square and b cube in the columns. Right, so see, there are 4 columns and which are awaiting the writing of all these things. So let us make the categories. So the first column would represent a cube, second column would represent 3a square b, third column will represent 3ab square, and the fourth and final column will represent b cube. So 2 cube is equals to 8, so we can directly fill it. Now 3a square b, so 3a square would be 4, and 4 into 5 would be 20, and 20 into 3 would be 60. Similarly 3ab square, so 5 square is equals to 25, 25 into 2 would be 50, 50 into 3 would be 150, and b cube, that is 5 cube, would be 125. So that was the first step, right? So that was the first step in which we had taken a is equals to 2, b is equals to 5, and then we have written the values in the columns, right? Now the step number 2. What is step number 2? So step 2 says that now underline the unit digit. Now underline the unit digit of b cube and add the remaining values to the column of 3ab square, right? So first of all, let us bring question to the present format, which is a cube 3a square b 3ab square and b cube. Here we had 8, here we had 60, here we had 150, and here we had 125. So now what this method says is, this method simply says that underline the unit digit in b cube. So the unit digit in b cube is 5, so we have underlined it. Then add the remaining digits, which is 12, to the column of 3ab square, that is the previous column. So we'll add this remaining 12, and what we'll get? We'll get 162. Okay, so this was the step 2. So what step 2 said? That underline the unit digit in the b cube and then add the remaining digit in the previous column, that is the column of 3ab square. Okay, let us now write the step number 3. But before writing the step number 3, let us bring the question to this format. So it was a cube, it was 3a square b, it was 3ab square, and it was b cube. We had 8, we had 60, we had 150, and finally we had 125. What we did was, we underlined the digit, we added 12 over here, and we got 162. Now the step number 3 says, again do the same thing. Again, now, comma, underline the unit digit of values of 3a square b, underline the unit digit of values of 3a square b, and add the remaining values, the unit of values of 3a square b, and add the remaining values to the column of this. So here it was 3a square b, right? So underline the unit digit of the values of 3ab square and add the remaining digits in the column of 3a square b, right? So again, now we'll underline. Firstly we had did the same thing in this column. We underlined the unit digit of b cube, added it to the column of 3ab square. Now after taking the final product, we'll underline the digits, unit digit of this 3ab square, and then add the remaining digit to the column of 3a square b. So let us underline the digit. So 2 will be this digit. Okay, so let us underline that, and let us add the digits to this column. So the remaining digits are 16. So we'll simply add 16 and we will get 76 over here. Okay, So this was the step number 3. Now let us move on to the next step. Okay, but before that, let us bring question to this particular format. So we had a cube over here, then we had 3a square b, we had 3ab square, and finally b cube. Since a was 2, so it was 8, it was 60, it was 150, and it was 125, right? Now we have underlined this digit 5 unit digit over here, we have added 12 over here, we got 162. Again we underlined 2, we added 16, and we got 76 in the last particular step, right? So now what this step says, so step number 4 actually asks you to do this one more time. Okay, so it says that underline the unit digit. It says that underline the unit digit of the values, align the unit digit of the values of 3a square b and add the remaining values to the column of a cube, right? A cube, and then so it was expected, right? Since we are moving leftwards, so first of all we underlined this column, then added to this column, then underlined this, then added to this 3a square b, and now we are underlining the digits, unit digit of 3a square b and adding it to the last column, which is a cube. And then what we have to do, and then underline its whole values, so you can say its whole digits, and underline its all digits. Okay, instead of all values you can write underline its all digits, right? So again we'll underline 6, okay, over here, that is the unit digit, and we'll add 7 over here, we'll get 15, and the method says that underline all the digits, right? Now what the last step says is, the last step that write the underlined digits, and this is the cube of the number. Okay, so for the last step, let us first write the digits, underlined digits. So this is 1, 5 underlined digits, then it is 6, here the underlined digit is 2, and here the underlined digit is 5. Okay, so what the last step says is, step number 5, which is the last step, it says that write the underlined digits, and this is the cube of the number AB is equals to 25. So 25 cube. Now what were the digits which we have written? 1, 5, 6, 2, 5. Okay, so that is the cube basically. So 1, 5, 6, 2, 5. This was the column method to calculate cube. Now it is looking very long to apply, but this is very easy to apply when there is a 2-digit number, right? So let us solve some questions on based on this method to further strengthen the use of this method. So let us find the value of 29 cube with the help of column method. So first of all we will take AB is equals to 29, implies that A is equals to 2 and B is equals to 9. Okay, now let us construct columns. So this column should be for A cube, this is for 3A square B, this is for 3AB square, and this is for B cube, right? So these are the columns. Now let us find the cube. So first one said that A cube, that is it will be 8. This is 3A square B, right? So 3A square would be A square would be 4, and 4 into 9 would be 36, and 36 into 3 would be 108, right? So it would be 108, Now what is 3ab square? Now 9 square is equals to 81. 81 into 6, it would be 486. Okay, so it would be 486 and b cube would be 81. Right. So b cube would be 81. Not 81, it would be 729. It's 9 square. Yes, 9 cube would be 729. Okay, so that is the first step in which we have written all the cubes. Now the second step is very easy. It simply says that underline the digit at 72 to this digit. Okay, so we will get 6 plus 2 would be 8, 8 plus 7 would be 15, and it would be 558. Okay, then again the method says that underline this unit digit, right? Underline the unit digit of this number, add this number to here. So adding this will get 5 plus 8, it would be 13, 1 here it would be 6 and 1, right? Then again finally it says that underline this digit and add the remaining digits over here. So it would be 16 and it would be 24. Now underline all the digits, right? Then the number says that write all the underlined digits. So the underlined digit here is 24, here it is 3, here it is 8 and here it is 9. So see, that first was this method, so it will give us 29 cube to be 24389. Okay, so it was that easy. It would be 24389. Okay, now let us solve one more question. Okay, now let us find out the cube of 99 with the same method. So let 99 equals to AB, which implies that A equals to 9 and B is also equals to 9. Now again let us make the columns. So the first column would be of A cube, the second column would be of 3A square B, the third column would be of 3AB square, and the final and fourth column would be of B cube. So let us make them in the form of a column and let us calculate A cube. So A cube here would be 729. Okay, see, this is the highest two digit number which can be calculated, whose cube can be calculated using the column method. Now 3A square B, now A square, that will be 9 square, it would be 9, so 9 cube into 3 would be 2187. Okay, so that is also, it is large but it is easy to calculate, right? Because we are getting repetitive calculations. Again, B square into A, 9 square into 9 would be 9 cube into 3, again it is 2187. B cube again 9 cube 729. So calculation part in this method is kind of very easy because it is repetitive. Okay, now let us write them in a separate row. Now underline the unit digit 9 over here, 872 to this number. It would be 7 into 2 9 and 8 and 7 would be 15. 2259 would be the number which we will get here. Okay, then the next step says that underline its unit digit which is 9 and add the remaining number which is 225 to 2187. 5 and 7 would be 12 over here, so 1 would be carrying, 8 and 2 and 1 would be 11. 1 over here and 1 would be carrying, it would be 4 and it would be 2, right? Then the next step says that underline the unit digit and add the remaining digits which are 241 in this case over here. We'll get 0, 1 carrying, so 6 and 7 and 7 into 9, so we'll get 970. And it says that underline all its digits. Okay, so let us underline all its digits. Now writing all the underlined digits, we will get 970 over here, here 2, here the underlined digit is 9 and again it is 9. So 99 cube is equals to 970299. So again it was very easy. Now you can see that it is not time consuming either. Okay, we just have to follow the method. Okay, method in itself, why this method has been created? Just to save the time, so it will not be very time consuming. Now let us find the answer of this question, which says that is 343 upon 512 a cube of a rational number. Now recall students that a rational number is a number which can be written in the form of p by q, where p and q are integers and q is not equals to 0. So let us see that if they are the square of integers. Okay, now obviously there is a positive number and cube of a positive number is positive only. So if they are the squares or if they are the cubes of natural numbers, then we can say that yes, this whole fraction is a cube of rational number. So let us find out individually. Okay, in this fraction, let us resolve the numerator and denominator into factors and see that what whose cube are they. So adding the digits, the sum comes to 10, so it will not divided by 3 nor divided by 5 either. Let us check with 7. 7 into 4 would be 28. Yes, it goes 49 times, it goes 7 times, and it goes 1 time, right? So you can say, implies that 343 is 7 cube. Okay, let us check about 512. So 2 it will be 256, then again with 2 it would be 128, then again 2 it would be 64, then again with 2 it would be 32, then 2 it would be 16, 2 it would be 8, it would be 4, it would be 2, and it would be 1, right? So making the triplets out of it, we'll get yes, they are perfect triplets. So implies that 512 is equals to, now we'll take 111 from each, so it will be 2 into 2 into 2 cube, which implies that 512 is equals to actually 8 cube, right? So yes, we can say that, which further implies that 343 whole upon 512 is nothing but it is 7 cube, and this 512 is 8 cube, and using the exponents and powers we can see that yes, it is 7 by 8 whole cube. So 7 by 8 is a rational number, so yes, comma 343 upon 512 is a cube of a rational number, right? So yes, 343 upon 512 is a cube of a rational number. So I hope you all got my point. Now let us see the next question. It says, check whether 106480 is a perfect cube or not. If not, then find the smallest number by which this must be divided so the quotient is a perfect cube. Okay, so according to the question, it seems that it is not a perfect cube. So let us first check it. The only method to do so is using prime factorization method. So 106480. Let us divide by 2. So it would be 5, then it would be 3, it would be 240. Again dividing by 2, we'll get it would be 2, it would be 6, it would be again 6, 2 and 0. Again it can be divided by 2, so it will be 13310, and clearly again can be divided by 2, so it would be 6, it would be again 6, it would be 5, and it would be 5. 6655, right? So again 2, so yes, 6, 6, 5 and 5. Now again it cannot be divided by 2 further, so we'll add the digits. So 12 and 10, 22. It is not divided by 3 either, so we'll use 5. So it would be 5 and 1. This would go 1 and 16, so 3 times, then 3 times, and then 1. Okay, then obviously we know that it will not go with 5 and 7 either, because if you have learned the table, then it is 11 cube. So see, that is what learning the cube makes it easier. It makes the calculation faster. So you can clearly see that over here, if we see the prime factorization of 106480, we get 2 into 2 into 2 into 2 into 5 into 11 into 11 into 11, which would be 2 cube into 11 cube into 2 into 5. So these two factors are not having any triplet, which is again equals to 2 into 11 whole cube, right, into 10. So we can see that it's not a perfect cube. since 10 has no triplet, comma, so 106480 is not a cube, or you can say it's not a perfect cube. Okay, I was writing it, but it's not a cube of a natural number, so the word for that is it is not a perfect cube, right? So it is not a perfect cube. So how can we make it perfect? Just remove this 10. Okay, so comma 106480 should be divided by 10 to make it a perfect cube. Of what? 22. Perfect cube of 22. Okay, so after dividing by 10, we will get 10648, which is the perfect cube because it is a cube of 22, which is pretty clear from the prime factorization. So I hope you all got my point and you all learned how to calculate the cube using a column method. But again, this column method is useful only for 2-digit numbers, right? So this was all about this particular lecture. I hope you all enjoyed the lecture and you all got something to learn. And this column method is very easy to calculate, to save your time and to calculate the cube faster with the more accuracy, right? So there are very less chances of mistakes. So I hope you all got my point. This was all about this lecture. Thank you for watching this lecture till end. We'll meet in the next lecture. Till then, goodbye.